Hello, good morning to all. Today we are talking about water and wastewater engineering. In this water and wastewater engineering subject, we'll start with water treatment mechanisms. And the first topic of discussion is water treatment basic objectives. So, what we are having in this basic objectives, if you look at normally, we need to have a source. So raw water source will be there. It can be your lake, it can be your river, it can be reservoir, canal, anything is there. And we go for one intake structures where water is drawn from the source into the intake structures. This water is now at a low level compared to the ground level. So usually this is pumped at the intake structures, and then it will going to through a pump into some treatment system, you can see here. So this is your entire treatment system. This is the entire thing what we are calling as a treatment system. So this is your pumping system, low level to high level, and then you are going into a treatment system. So this is your treatment plant. So this is your pumping here, and then afterwards you're having different units within the treatment plant, and finally you are going into the treatment plant. It will be at low level, and it should be reaching to the consumers at different elevations. So usually we'll send it through a distribution system. So this is your distribution system. I'm writing here DS. The distribution system, it consists of a series of network pipes, overhead tanks, reservoirs, etc. So from the reservoir, we are going to put a overhead tank. The water will be supplied through gravity, like this, to far off places. So to higher up elevations, so normally what we need to have is we need to have the pumping of the water. So again, you're having a pump which should again lift this water from the treatment plant point of view to the different storage structures. From storage structures, it is now reaching into the different consumers within the city. So this is what is overall water treatment system. Okay, and what are the engineering aspects here, and that we will try to discuss in this module. So if you look at the different water sources on the earth, so and 75% is the water are there and 75% is land. Everybody knows. Out of this 75% water, only 1% is drinking water. Remaining is sea water, and a very small amount of water is available for drinking here. So most of the water is sea water, saline water, which is not suitable for drinking. So what we need to do is we need to conserve that water, and whatever is available, we should be very careful with that. Okay, so that is what we have to look carefully in this. So everything depends on your hydrologic cycle. So everybody knows the hydrologic cycle is what is there. The water is there in the surface. It will get evaporated into the air, the high temperatures. Then it will undergo condensation in the clouds, and after condensation, then it will fall back onto the ground in the form of a precipitation, and then falling back onto surface water. And plants also will release its moisture in the form of transpiration. So this is transpiration and evaporation. This transpiration and evaporation put together, so they are real now coming back in the form of precipitation through condensation principle. So the most important source here is primary source is mainly the rainwater. So that is the rainwater is the major source, and at the surface we are having rivers, lakes, ponds. Groundwater we are having wells are there, infiltration galleries will be there, springs will be there, and also after using this water, some of this water becomes waste here. So we have the treatment plants, wastewater recycling plants, and we try to recycle this wastewater, and then we will be using for different purposes. Maybe for gardening we can use. When you are using some recycled water, that much of treated water, untreated water, or raw water is being saved. So how much amount of recycled water you are using is equal to the amount of water that is saved here. This is how we try to understand the recycling water here. So now let us look at the quality. What is the problem with these type of water sources? The rainwater is coming down. So this is the first source of water here. Earlier, we used that feel that the rainwater is mainly purest form of the water because it is going through condensation and evaporation process. All the unwanted things are removed. So, but what is happening is because of atmospheric pollution within the atmospheric pollution in the atmosphere, this rainwater will pass through that pollutants in the atmosphere. The pollutants like SO2, NO2, dust particles, and other unwanted gases also will be there. So this water will pass through that unwanted material, and then we are having all the different contaminants such as dissolved gases, particulates, and then different salts based on the chemicals which are used, and the dissolved chemicals, the chemicals which are immediately dissolved in the rainwater. The acid rain is one of the best example here. The acid rain is best example here is when sulfur dioxide is more in the air and then get trapped with the water coming down in the form of sulfurous or sulfuric acid converting into acid rain. Similarly, nitrogen dioxide converts to nitric or nitrous oxides and subsequently going into the ground in the form of acid. They are causing damage. So that's how we talk about the impurities which are there in the rainwater. Then surface water is again through the rivers and etc. So normal season is all right, but during rainy season, so it will travel and from far off places, it having different catchments. So although always you'll have soil erosion. So suspended material will be there. It is giving rise to a lot of turbidity. That means the suspended particles, some color changes will be there, and there are some dead bodies and vegetable material which are there. Then they are going to create bad smells also, and depending on the chemicals which you throw into this river water through surface drainage, the dissolved chemicals will be there. The agricultural runoff contributes to different sorts of pesticides, and then the heavy metals coming from industrial wastewater joining into the surface water bodies. Similarly, groundwater again will have a simpler sort of impurities, but a very small content of suspended material because it's directly filtered directly into the groundwater. The most thing is water that has percolated into the ground. So mainly it is the chemicals, inorganic as well as organic chemicals, okay, like carbonates, chlorides, heavy metals, and also dissolved gases. What are dissolved gases means? The septic tanks are there, as well as what you say, garbage dumps are there. So due to the reactions which are happening in these things, the carbon dioxide, methane, hydrogen sulfide, etc., will directly go below the ground level through the voids, and then that will dissolve in the water because these gases are heavier than the air. They cannot go up. Primarily, they will try to go down from the below ground level sources, and they will give some acidity to the water. So that is how we have the dissolved gases. And septic tank leakages, wherever is possible, they will also be another problem where you are having the contamination in the groundwater. Recycled water is also there, but we have treatment plants normally constructed in every places, but the quantity and quality of the impurities depends on the degree of treatment. Now let us see the water treatment is mainly talking about the um, how to treat the water and what should be the objectives here. So we have seen some problems, all the different problems we have seen, what are the difficulties are there, impurities are there. So to remove the odor, dissolved gases, objectionable taste, and suspended material, and different dissolved chemicals like hardness, chlorides, etc. And salts also will be there, so they should be removed. And more importantly, whenever there is a biological contamination, the dead bodies and decayable material which is there in the water present there, so that will cause some amount of bacteria. So bacteria and other microorganisms should be removed. And finally, the ultimate objective is to make the water suitable for drinking purposes. To achieve this, the unwanted things like all these things should be removed. That's all. That's what it is. And what are the treatment units we have, or what are the basic principle of operation, and which type of contaminants we are going to remove here. So mainly the floating material, particularly when you're using surface water bodies. Here we are using floating material, and that floating material normally like trees, leaves, stems, all those things will be coming during particularly in the this thing rainy season. And what are the things which you are going to throw in the rivers, like fruits, peelings, flowers, etc., during some offerings to the rivers? All those things will be floating, and if you are not removing this, it will create a problem during what we call pumping of the water for the treatment. So it should be removed. How it will be removed? By obstructing it. If you put some obstruction, and then ultimately what will happen? The large particles will be stopped there, and only water is allowed to pass through. That process is called as screening. And similarly, the particles, suspended particles, there are inorganic as well as organic are there. The major problem comes with the inorganic particles, larger size, and they will be settled in a tank using a principle called sedimentation. Sedimentation is nothing but settling of the particles by gravity. So here the treatment unit which you are going to employ is a plain sedimentation tank. Similarly, the suspended material, fine sized particles are there. So they take more time for settling. So therefore, we add some chemicals to aid in the quick settling of the particles. The chemicals which we are adding called coagulants like alum and iron salts, and that particular process is called coagulation. And that process we normally adopt along with sedimentation. So it is called as a coagulation aided sedimentation tank. And clariflocculator is one such a unit which is adopted, where a clarifier sedimentation tank along with the coagulation system is added, embedded into that. So now colloidal and biological solids. These particles, suspended particles, will be in size, millimeter size, up to point greater than point 0.1 is we are calling as a coarse size, and less than point 0.1 is a fine size, and up to 1 micron size. So, but less than 1 micron size particle also will be there, along with some viruses. So these collide, they are called as colloidal particles. And these colloids and biological solids very difficult to remove because of very fine size. They take large amount of time. So they will be removed through a process called filtration. We are using a filter beds, some filter material we are going to use. That filter bed will help in removing all these particles. And we are having that rapid sand filter and slow sand filter as a treatment units for this type of situations. And the destruction of bacteria and viruses, and how exactly we are going to remove other than the small amount of biological solids which are removed in the filtration. Here we go with a process called disinfection. Disinfection means, dis means separation, infection means infection causing agents like viruses. So we normally apply chlorine, ozone, UV treatment, ultraviolet rays treatment, which is a process where they're going to destroy the microorganisms. And household treatment, generally we are using ozone and UV treatment with the filters which we are adapting in the kitchen for drinking purposes. And dissolved gases also we have discussed. They'll be particularly there in the groundwater. So they dissolved gases, and then how they will be removed through aeration or gas transfer. So exposing this type of water into the air, then ultimate what will happen is these gases will get oxidized. For example, methane is there. Methane will get oxidized to carbon dioxide and water vapor. Hydrogen sulfide, for example, is there that will get oxidized to sulfur dioxide. Similarly, ammonia also will get oxidized to nitrogen and other different components. So like this, we have the mechanisms, aeration, gas transfer. Along with that, some dissolved inorganic chemicals also will be there, like iron and manganese. They will also be removed through oxidation, like iron oxide, manganese oxide, and all those. So we have a procedure called cascade towers where we expose this water into the air for a specific period of contact time. Then some dissolved solids are there, which are depending on industry or source specific generation. We have a process called ion exchange and reverse osmosis. And similarly, odor and color, they will be removed through a process called adsorption. And these are mainly specific processes and generally called as advanced treatment operations, as specific treatment operations. But in general, for any water treatment plant, we adopt mainly these operations in a common platform. That's why we discuss mainly these four or five different categories. So now you see in the water treatment process, you're having a raw water is there, and we are adding some coagulants like alum or iron oxide, and we mix them here, the rotation, and where the chemical will get dissolved, and then the fine particles will get attached to the ions, positive ions in the coagulant. Then we are having another process called flocculation, where the attached particles will come together and form a bigger mass, and they will be settled down in a sedimentation tank because of the gravity. So these three units put together, we are now calling as coagulation aided sedimentation tank. It is not plain sedimentation, called coagulation aided sedimentation tank. We'll discuss these details when we go into individual units. Similarly, the filtration part, we also discuss it there. Here you see here, this is the water. This is water here. And there we are having sand bed. There's a filter bed here. And then at the bottom, we are having a gravel, a supporting. And then water is allowed to pass from the top into the filter bed. And clear water is now collected from the bottom. It will go out from the filter bed, and subsequently the disinfection process where chlorination or other things will be given here, and afterwards the water is cleaned and then collected in a storage tank, and from there either it is pumped to the individual houses or through your elevated water tanks it will go into the houses. Okay, so this is a nutshell the general conventional water treatment process. So let us see here the first one, the bar screens or screening process where the objectionable material is removed, the large floating material is removed here. So what you see is a screening is nothing but a mesh. It can be either vertical, it can be installed as vertical, or it can be put directly inclined to the flow. So like this or like this. So what will happen is, whatever the unwanted material here, you see some gaps are there between the screens, what you are calling as the spacing. And they're having some bars. Bars are also having some spacing. The screens are classified based on the diameter and spacing. So bar screens, coarse screens having 20-25 mm size, 75 to 100 mm spacing. So less than 20 mm up to 5 mm, we are calling as medium screens, and below 5 mm up to 1 mm, we are calling as even micro screens, very fine screens. So what will happen in this process, you see, when large floating objects come here and they, because they are larger than the spacing on the screen, they will get stopped here. They will get stopped. They are intercepted here. Intercepted here. So ultimately, what we will do is we will have a scraper mechanism, which we are using it from the top, and then you are going to scrap it everything into a collection point. So now what you see here, here you can clearly understand. Here you see a platform is provided and water is coming in this direction. So automatically what you see here, the unwanted things which cannot pass through this screen spacing, they are stopped here. Somebody can stand over here and use some mechanism to wipe off all these things and then keep it a pit. A pit will be done, kept there, and they put everything the screenings into that pit collection point. Right? If you are not doing this, what will happen is this will create an obstruction in the pumping of the water. Right? So usually the inclined bars will be more used so that you cleaning your operation is much more helpful. Then another one is if the vertical operations are there also there, but here the cleaning operation is slightly difficult because of that automated cleaning mechanism like belt conveyor with scrappers. They're automatically embedded here, so they will be continuously rolling, pushing all the particles up to a collection point like this. You're having collection point. Some collection point, you're going to keep it here. All these things will be dumped there into the collection point, right? So this is how we are having the bar screens. The other one is the aeration to remove the dissolved gases or create more oxidation process. So the gases, whatever are there, so they should be removed along with some uh, inorganic salts like iron and manganese. They should be converted into the corresponding oxides. Here, what you have to remember is the entire process. We are talking in terms of two states. One is gas, another is water. Two different phases, gas phase and liquid phase. So we are saying that the oxygen, water in the air, it should get mixed here with the dissolved salts in the water. Or whatever the excess things are there in the water should go out into the air and get mixed in the air, which is not easily possible. So what you are going to do? So two different phases are there. So what you call as a two-phase mixing. So what you see is this is the interface. Interface means the water level. So interface means it's because the above which you are having gas, below which you are having a liquid. That's why it's calling as interface. So now something which is coming out from the gas into the liquid will have a blockage at the interface. Something which is something going out from the liquid to the water, again liquid through the gas will again have some difficulty in the moving out of the interface. This is again a friction. So two frictional layers are provided and generated here, generated at the interface, liquid gas to the liquid and liquid to the gas. Unless until these interface frictional layers are broken, you cannot allow these things to be converted. So what you are going to do is we are going to put some sort of a turbulence by agitation of the surfaces. So this agitation will give you the momentum transfer of the gas from atmosphere outside to inside or inside to outside. These things will be possible. So again, it depends again on the concentration. Every gas you're having some saturation concentration at a given conditions, at a given condition, temperature and pressure. This is called saturation concentration. If your saturation concentration is greater than the concentration at any given time, this is going to have desorption. If saturation concentration is less than the concentration, you're calling as absorption. For example, here, suppose you're talking about oxygen to be transferred. So in the water, the normal concentration at 20 centigrade is 9.2 milligrams per liter at 20 centigrade. If the concentration of dissolved oxygen in the water, say less than 9, so maybe 8.8 milligram per liter, that means what? The saturation concentration is not reached, still having some space to occupy that concentration. So automatically what will happen is it will accept oxygen from atmosphere to inside. Suppose the concentration in the water, say it is 10 milligram per liter, this at 20 centigrade. So then ultimately what will happen? The concentration is more than the saturation concentration. So on excess concentration should be removed. So automatically what you are saying is you're saying this will go up. All these things will happen only when there is a proper turbulence. If the proper turbulence is there, rate of reaction will be much faster. The rate of the turbulence is not provided and is not sufficient, the transfer will be very slow. That is the process. This is a natural mechanism occurring in the rivers. While rivers are flowing, it will have different velocities, low velocities and high velocities. Then the high velocities, the oxygen transfer will be much, much faster from the air into the water, so that oxidation will take place, and also dissolved oxygen concentration will increase in the water. Similarly, the other way around. So during summer, particularly, the lean flows will be there. So there, the movement, the turbulence is not much created. So there, what you are going to see is the problem of less oxygen transfer. How to do this? Now you see we are having different cascade towers, the basic things which are constructed. So raw water is there. You are now from the tank. You are having a tank here, and you are allowing the raw water to flow through a series of steps. So what you're seeing is now it is falling through a step from the fundamental law of physics. To fall any object from a particular height, it will undergo some time. It will take some time of fall, say T1, T2, maybe T3, etc., etc. That means that during this period, this liquid will be exposed to oxygen in the atmosphere. Then again, another point from the fluid mechanics point of view, when the water is falling, the potential energy is now getting converted to kinetic energy. Kinetic energy means nothing but the velocity. When the velocity of the water flow is more, it is never been laminar now, it becomes turbulent. So a turbulent flow, the velocity pattern is changed, the flow pattern is changed. So more and more oxygen will transfer as the frictional layers will get disturbed. Then the frictional layers will not disturb and then allow more oxygen transfer. So everywhere you are having that velocity, excess velocity is created. And finally, when you reach to a point where these excess gases, either higher concentration in the water, they will escape into the air. If something is less than in the water, that will get added into the air. All such type of things will happen. And what you are going to see is your treated water which is now entering into the thing. So number of cascade towers are there, configurations. You see here, this is one way of stepped configuration. This is another way of stepped configuration. This is another way of stepped configuration. So these are generally provided in the water treatment plants to provide the excess of oxygen transfer into the water, so that oxidation is going to take place. So this is all about the different sources of water. Now the basic objectives, what are the likely impurities in the water, and the fundamental operations of screening as well as gas transfer. So in the next module, we will be talking about the sedimentation process, which will help to remove the coarser particles. Okay, and thank you very much. And if you have anything to